Pluto, once considered a distant and modest planet, was originally part of our solar system's planetary family. However, after controversial statements by prominent astrophysicists such as Neil deGrasse Tyson and Michio Kaku, Pluto has recently been thrust back into the spotlight. These experts suggest that Pluto might be on a potential collision course with Neptune, a startling revelation that raises questions about how this could happen and what the consequences might be. Could this be an intriguing cosmic anomaly? Or is there more to this approaching cosmic event? Let's delve into the potential outcomes of a Pluto-Neptune collision. Pluto, once downgraded to a dwarf planet in part due to its unusual orbit, remains a subject of fascination in the astronomical community. Recent predictions from leading experts indicate that Pluto's orbit is alarmingly close to Neptune's, which has raised concerns of a potential catastrophic collision between the two planets. But how could such an event occur? Pluto's journey around the Sun is unlike any other planet. It takes an astounding 248 years to complete one orbit, meaning that since its discovery in 1930, it hasn't even finished a single full revolution. However, Pluto's orbit is even more intriguing due to its elongated shape, contrasting sharply with the nearly circular orbits of the other major planets. What makes Pluto's orbit even more bizarre is its tilt of 17 degrees relative to the ecliptic plane, making its path much steeper compared to the other planets. This eccentricity adds complexity to its orbital behavior, but perhaps the most fascinating aspect of Pluto's orbit is its resonance with Neptune. For roughly 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune. This unusual overlap naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. Early astronomers struggled to understand Pluto's peculiar orbit, especially since its path diverges significantly from the relatively flat orbits of other planets. As scientists examined Pluto's orbit more closely, they realized that Pluto's orbit does indeed cross Neptune's at certain points. However, the planets have never collided, thanks to a delicate gravitational dance between them. This phenomenon is explained through a concept known as the three-body problem, which involves calculating how three objects in space, such as Pluto, Neptune, and the Sun, interact with each other gravitationally. Understanding this interaction helps predict the future paths of these objects based on their initial positions and the gravitational forces they exert on one another. In the case of Pluto, Neptune, and the Sun, their movements are stabilized by gravitational interactions that prevent the planets from colliding. A key factor keeping Pluto and Neptune in their separate orbits is a gravitational effect called libration. This term refers to the way Pluto and Neptune remain at least 90 degrees apart in their orbits when Pluto crosses Neptune's path. This spatial separation prevents a direct collision. Additionally, another protective factor is scope libration, which describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes close to Neptune or any other giant planet, it is positioned far above the orbital plane of the other planets, providing an additional layer of safety. Another important factor is VSK precession, named after three scientists, VAVA and KI, who studied the gravitational effects of multiple bodies in space. VSK helps explain why Pluto's orbit is so unusual and how it remains stable over time despite seeming irregularities. This precession ensures that Pluto's orbit stays relatively stable, preventing collisions with Neptune and other celestial bodies. While Pluto's orbit may appear chaotic, these gravitational effects, including libration and VSK precession, work together to keep Pluto's orbit intact over vast periods of time. Numerical simulations in the late 1980s revealed that while Pluto's orbit does experience some minor deviations, the long-term stability of its path is maintained. These findings have helped us understand how the gravitational pull of massive planets like Neptune, Jupiter, and Saturn can influence the orbits of distant bodies like Pluto. In conclusion, while the idea of a Pluto-Neptune collision seems alarming, the gravitational interactions between these two planets ensure their orbits remain stable. These celestial mechanics continue to offer valuable insights into the nature of our solar system and beyond. Pluto's orbit around the Sun has an interesting dynamic with Neptune, as for every 2 orbits Pluto completes, Neptune completes 3. This gravitational resonance helps stabilize Pluto's orbit. However, Neptune isn't the only planet involved. Jupiter also plays a significant role in maintaining Pluto's orbit, and Saturn contributes as well. Research shows that Jupiter's gravity alone is strong enough to ensure Pluto remains on a stable orbit for an incredibly long time, potentially even billions of years. Together, Neptune, Jupiter, and Saturn cooperate to keep Pluto on a steady path in space, preventing any potential disruptions. These gravitational interactions are crucial to the broader structure of our solar system, as they help maintain order and consistency in the movements of celestial bodies. Without these stabilizing forces, the solar system could experience much greater chaos. For Pluto, this is especially important, considering past discussions about potential collisions with Neptune. Understanding Pluto's orbit is key to predicting the long-term stability of the solar system. Pluto's orbit also highlights the delicate and ever-changing nature of celestial mechanics. Even orbits that seem stable on the surface can be subject to shifts due to the intricate gravitational forces at play. This phenomenon, known as orbital chaos, describes how a planet's orbit can be highly sensitive to its initial conditions. Even small changes in Pluto's position or speed can dramatically alter its orbit over time. Virtual simulations have been instrumental in helping scientists understand how Pluto moves in space. These models use complex mathematics to simulate the gravitational interactions between Pluto and other objects, revealing how even tiny changes can have significant effects on Pluto's future path. Despite this apparent unpredictability, Pluto's orbit remains stable over long timescales, likely for billions of years. This illustrates that even in seemingly chaotic systems, long-term order can still be maintained. However, predicting future events in such systems is highly challenging. The inherent unpredictability of these orbits means that long-term predictions are fraught with uncertainty. While simulations provide valuable insights into the future behavior of celestial bodies, they are limited by the precision of their initial conditions. Even small errors in the data can lead to vastly different outcomes, making precise forecasts difficult. Pluto's orbit serves as a reminder of the dynamic and evolving nature of the universe. Although we have made significant progress in understanding space, Pluto's orbit underserves the limits of our current knowledge. By studying the gravitational effects of the giant planets on Pluto's orbit, scientists gain crucial insights into the larger workings of the solar system, showing how the positions and interactions of all the planets can influence the stability and trajectories of other objects in the system. This leads to an important question. Why are astronomers only now raising concerns about a potential collision between Pluto and Neptune, despite all these stabilizing forces? Renowned astrophysicist Neil deGrasse Tyson offers a unique perspective on the mysteries of our solar system, especially in relation to Pluto. Known for his involvement in the reclassification of Pluto from a planet to a dwarf planet, Tyson emphasizes that our understanding of the solar system is constantly evolving. He views the renaming of Pluto not as a demotion, but as a necessary adjustment to our growing understanding of the diverse bodies that orbit the Sun. Tyson believes that the complexity of Pluto's orbit, along with its interactions with Neptune, illustrates the unpredictable nature of space. While Pluto's orbit is stable for now, Tyson suggests it could undergo significant changes in the future. This makes the study of Pluto's path crucial for understanding the broader forces at work in the solar system. As Tyson often points out, science is always advancing, and Pluto is a prime example of how new discoveries can reshape our understanding of the universe. Despite the current stability of Pluto's orbit, Tyson remains mindful of the dynamic nature of our solar system and the possibility of future changes. In the future, shifts in the gravitational interactions between Pluto, Neptune, and the Sun could lead to unexpected changes. The delicate balance that currently keeps Pluto's orbit stable might eventually be disturbed by alterations in the Sun's gravitational influence, the evolution of other planets, or even the impact of new forces that have yet to be discovered. Tyson's focus on these future uncertainties serves as a reminder that the universe is a constantly evolving system, and what appears stable today may change in unforeseen ways. His warning about the possibility of a collision between Pluto and Neptune highlights the evolving nature of our understanding of celestial mechanics as we continue to study Pluto and its unusual orbit. As we observe Pluto, we must consider how gravitational forces and the complex interactions between celestial bodies will shape the future of our solar system. While the likelihood of a Pluto-Neptune collision is remote, it emphasizes the importance of ongoing research and our need to continuously refine our understanding of the universe as new discoveries emerge. It is highly probable that our understanding of space-time and gravity will evolve, revealing surprising and awe-inspiring phenomena. This journey of exploration will guide us as we search the stars for answers to questions that have long eluded us. Although Pluto's future might seem uncertain, each new study helps us learn more about how our solar system functions. The intricate dance of planets like Neptune and Pluto reminds us of the vast complexity and grandeur of the universe. Despite the apparent stability of Pluto's orbit for the foreseeable future, the potential for change remains ever present within the chaotic nature of space. Pluto's journey through space, despite its current stability, is far from simple. As a dwarf planet, it offers a unique perspective on the complexities of celestial mechanics and the forces that govern the solar system. The fact that its orbit crosses Neptune's without leading to a catastrophic collision challenges common assumptions. This fascinating scenario invites further exploration of how various forces work together to prevent collisions in space. While Neptune's gravity is often seen as a dominant factor in shaping Pluto's orbit, the interactions among all the planets, especially the gas giants, are crucial in maintaining Pluto's orbit. Jupiter, with its immense size, plays a vital role in this gravitational dance, helping to stabilize the more erratic bodies in the outer reaches of the solar system. Saturn, with its massive rings and gravitational pull, also contributes to the overall stability of planetary orbits. These giant planets act as cosmic shepherds, ensuring that Pluto's orbit, despite its eccentricities, remains largely safe from danger. In addition to the gravitational influence of other planets, the Sun's gravity remains the ultimate force shaping the orbits of all objects in the solar system, including Pluto and Neptune. The Sun's pull dictates the general pattern of orbits and provides the fundamental stability of the solar system. However, the Sun itself is not static. It undergoes various cycles of activity, including solar flares and changes in its magnetic field, which could, over extended periods, influence the orbits of distant bodies like Pluto. These changes, though subtle over short time frames, might eventually alter how Pluto and Neptune interact in the distant future. Studying Pluto's orbit not only gives us insights into the past and present conditions of our solar system, but it also sheds light on how planetary systems evolve over time. Although Pluto is currently safe from a direct collision with Neptune, the dynamic nature of the solar system means that no orbit is truly fixed forever. There are forces beyond gravity that influence the movement of celestial bodies. Even the smallest disturbances in a planet's orbit can lead to significant shifts over time. This unpredictable motion is one of the fundamental characteristics of the universe, constantly evolving and presenting new mysteries for astronomers to solve. The possibility of a future Pluto-Neptune collision, while extremely unlikely in the near term, underscores the idea that even stable systems can behave unpredictably over long timescales. By modeling the orbits of objects like Pluto, scientists not only gain a better understanding of the current structure of the solar system, but they also uncover valuable insights into the forces that might shape its future. Simulations of Pluto's orbit have shown that its path around the Sun is vulnerable to slight changes in initial conditions. These minor variations, when amplified over millions or even billions of years, could ultimately result in major changes to its orbit, potentially bringing it closer to Neptune's path. Ongoing research into Pluto's orbit raises the question of whether other dwarf planets or trans-Neptunian objects might someday experience similar interactions with Neptune or other larger planets. The outer reaches of the solar system remain a realm of great mystery, with many objects still to be fully studied. Investigating the dynamic relationships between these bodies could reveal more about the forces that govern orbital stability and the eventual fate of the solar system. Ultimately, the future of Pluto, as well as the rest of the solar system, will depend on a combination of gravitational, physical, and perhaps unknown factors that scientists are still working to understand. The complexities of planetary motion offer a glimpse into the distant future of the solar system, where even seemingly stable systems are always subject to future changes.